Welcome back to Data Talks Live. I aim to cut through the spin, jettison the hype, and get to the data-driven core of the issue. Today, we're going to dive deep on a few seemingly disconnected anomalies, but the connective tissue is, what does it tell us when nature, technology, and power collide? We'll run 3 threads: the weird signals around the 3i ATLAS, and its possible link to the 1977 WOW signal, including its angular alignment, power estimates, compositional oddities, and trajectory alignment, the dawn of new computing power, OpenAI and AMD deal, and the rising ambition of nuclear-powered data centers, Rick Perry's Fermi, and SMR, small modular reactors, and why it all matters when cosmic anomalies and terrestrial power structures overlap. How do we maintain rational inquiry? Let's begin. So 3i ATLAS and the WOW signal, and what's anomalous? So 3i ATLAS, for those that don't know, is an object, an interstellar space object that's anomalous. It's large. It seems like there isn't enough material in interstellar space to generate an object this large. I've heard reports of it's much larger than other interstellar objects that we've discovered. And for those that don't understand how this might be related to the WOW signal, I'll explain. In 1977, the Big Ear radio telescope recorded a narrowband radio burst lasting 72 seconds, known as the WOW signal. Recent work by Harvard astrophysicist Avi Loeb suggests the interstellar object 3i ATLAS might lie close to that direction. Loeb cites angular offset of 4 degrees in right incession and 8 degrees in declination between 3i ATLAS' projected 1977 position and the WOW signal. So he assigns the chance of a random directional alignment this tight to 0.6%. That 0.6% figure doesn't prove causation, but it elevates the hypothesis from trivial coincidence to something worth scrutiny. So if 3i ATLAS were the transmitter, how strong would the emission need to be? Considering its estimated distance in 1977, which is 600 astronomical units per lobe, with a signal strength of 54 to 212 Jansky at 1420 megahertz, Loeb estimates the transmitter would require between 0.5 and 2 gigawatts of power, in the ballpark of a nuclear power plant's output. That's an extraordinary requirement for something traveling through space. It suggests, if it's artificial, whoever or whatever built it has serious power infrastructure. There are also composition anomalies pointed out by Loeb. Nickel without iron, which is an industrial signature, or could be. Another puzzle: spectral and compositioning readings of 3i ATLAS suggest an overabundance of nickel emissions without corresponding iron, which is odd. In planetary formation and stellar nucleosynthesis, nickel often coexists with iron. That asymmetry, nickel without iron, is reminiscent of some industrial or refined processes, such as smelting or alloy production on Earth. Some observers see this as a possible signature of technology or engineering rather than pure natural origin. However, this remains speculative and contested. There are some other things interesting about its trajectory and its eclipse alignment. 3i ATLAS follows a highly hyperbolic interstellar inbound-outbound trajectory. Intriguingly, some models show its approach aligned in such a way as to occasionally cross the Sun-Earth line of sight conditions near Mars, effectively blotting out or interfering with certain observational windows. Some proponents see this as not purely coincidental if the object had an active orientation or shielding capabilities. So essentially, it's coming from a direction where when we are able to observe it, the glare of the sun is going to make that more difficult. Because this alignment is rare, it raises the question, is its path purely gravitational or subtly controlled? Now here's the really speculative part. There's a timing overlap here with the government shutdown and technology deals. One more odd layer. Much of this cosmic speculation resurges right when earthly institutions are under strain. A U.S. government shutdown, tensions over power supply, energy infrastructure, and demand for compute. What does it mean when mysteries in the sky are discussed at the same time as a crisis on Earth? That juxtaposition invites reflection, even if not causality. Bottom line, none of this proves extraterrestrial engineering, but the coincidences are non-trivial. A 0.6% alignment, power requirements in the gigawatt range, compositional oddities, and a path alignment suggests that we should treat 3i Atlas as a legitimate anomaly demanding rigorous observation and not dismiss it out of hand. So next on the episode, we're going to talk about the OpenAI AMD deal and its nuclear data center ambitions. So let's pivot back to Earth. The cosmic thread might inspire wonder, but this next part is urgent politics and infrastructure. OpenAI and AMD have struck a major computing deal. OpenAI will acquire processors with 6 gigawatts of power consumption. For scale, 1 gigawatt of compute infrastructure can cost tens of billions of capital development for chips and supporting infrastructure. So 6 megawatts is massive. As part of the deal, OpenAI may take up to a 10% stake in AMD through warrants tied to performance and deployment. I'm seeing this a lot lately of companies taking stakes in other companies, the U.S. government taking stakes, the U.S. government and companies taking stakes in other companies. So there's a lot of interesting movement that I'm not sure has precedent or a lot of precedent in the U.S. economy. The move signals a consolidation of compute and power assets. OpenAI is not just buying chips, but controlling stakes in chip makers, increasing vertical integration. That deal is happening just as debate intensifies about how to power data centers in a carbon and cost-constrained world. Enter Rick Perry's nuclear-powered data centers, the Fermi or Project Matador, a new company co-founded by former Energy Secretary and Texas Governor Rick Perry, builds a massive data center campus in Amarillo, Texas called Project Matador as part of the hypergrid. Its target, 11 gigawatts of power capacity at full scale, combining nuclear reactors, multiple 1 gigawatt units, natural gas, solar, and batteries. And in the short term, bringing 1 gigawatt online by 2026, relying initially on natural gas and solar as bridging infrastructure while nuclear phases are built. They've filed for IPO, raised capital, and sought a DOE loan backing, Department of Energy loan backing. Political overlay, naming conventions alignment with national nuclear policy ambitions. So why nuclear and why the small modular reactor interest? AI data centers require stable, dense, high-grade power. Traditional grids often struggle to guarantee that. Nuclear offers base load. Small modular reactors are the newer paradigm, factory-built, scalable with lower upfront costs and faster deployment, in theory. Some proposals in Fermi's filings reference SMR future adoption, though the primary plan is large reactors or hybrids. The challenge: nuclear construction is historically slow, expensive, and subject to regulatory delays, cost overruns, and supply chain bottlenecks. The U.S. has relatively few recent examples. So what's going on? Tech requires power. Power is expensive, constrained, and political. Ambitions to co-locate compute and nuclear energy collapse the barrier between infrastructure and algorithms. Why it all matters, from stars to servers. When anomalies like 3.1 Atlas prompt us to question our assumptions, they help us remind us to stay humble. In parallel, we're on the brink of redefining how we power the systems that define our societies: AI, data, governance, through ambition and risky nuclear infrastructure. The OpenAI AMD deal and Fermi's nuclear data center campus are stakes in the ground. They ask, who controls compute? Who controls power? And what happens if either side is misaligned with accountability? So when someone says, we saw a weird comet aligning with the 1977 radio burst, and Rick Perry is building nuclear data centers now, it might feel like two different stories, but at the root, there are stories about signal, energy, and infrastructure. We should be asking, if 3i Atlas were artificial, what motivates it? What power source and what logic? If we build atomic reactors for data, what are the failure modes, cost overruns, safety, and political capture? And how do we avoid turning technology, cosmic or terrestrial, into illusions of control? I don't wrap this up with grand conclusions. What I hope is that you see these anomalies, whether interstellar or terrestrial, as invitations to think rigorously, to demand data, to insist on accountability. When the cosmos interacts with computers, the temptation for narratives is strong. Let's keep the discipline, follow the data. Thanks for listening. Next time we'll look at how media narratives select what anomalies get coverage and which get blurred. And have a great day.